Hello everyone. Today we are going to learn 5.2 complement and the addition rule. Oops. Hold on one second. Yeah. The note is missing. All right, so we have learning objective here. Okay, what is complement? Complement event E consists of all the outcomes where E does not happen. So we are using complement of E denote not E or little C on the right top, right? So complement of event E. So let me write down first. So we read complement of event E. Yeah. Okay, so what is that? So let's make, we have a set like a sample space. Sample space. This is a set notation, right? So from 0 until 9, let's make event E. Let me just pick the number, random number, right? 0, 2, 4, 5, 7, and 8. Yeah. Okay. Then what's the complement of event E? So means that, think about this, right? Not belong to it, right? Not belong to it. Think not belong to E. Complement event E. Yeah. Okay. So that is, we can denote the notation is like that, right? Complement to event E. Yeah. Event E. All right. So what is not belong to E? 1 is not belong to E. 3 and 4, 5, 6, 7, 8, 9, right? Okay, we can use that. If we are using Venn diagram here, this is the Venn diagram. Oh, okay, no. Venn diagram. So we have event E has 0, 2, 4, 5, 7, 8. Then not belong to E, which is 1, 3, 6, 9. Make sense? Okay, then we have a formula. How do you find the probability of not event E, right? Complement of event E. Then we have 1 minus probability of event E. Yeah? Okay, so let's talk about this. What is probability of event E in that case? So number of event E over number of sample space. Yeah? Okay, then how many number of sample space? Let's take a look. The sample space is from 0 to 9, right? Okay, then there's a 10. How many number of event E? So there will be 1, 2, 3, 4, 5, 6. So it's a 6, which is 0.6. Yeah? Okay, then what is probability of event complement event E, right? There will be number of complement of event E, denoted like that, over number of sample space. Yeah. Then let's count 1, 2, 3, 4 complement event E, right? Over 10, which is 0.4, right? Okay. So we had last time all the probability between 0 and 1. Yeah, probability is number between 0 and 1. And their sum must be equal to 1, right? Okay, so if we add them together, so if we add the probability of event E plus probability of complement of event E, right? Then we get 6/10 plus 4/10, which is 10/10, which is 1, right? Or we can say the 0.6 plus 0.4, which is 1 as well, right? Okay, so if we have 1, if we want to find the only complement of event E for the probability, we can say that, right? So 1 minus the probability of event E. Yeah, makes sense? Since their sum equal to 1. Yeah, is it clear? So we have, let me write down this one too. So same as like that, right? So that's how we get the formula. All right, so we have an example. A statistics class has 32 students enrolled, 7 nursing majors, 2 journalism major, 3 kinesiology major, 3 English major, 1 history, 2 political science major, 8 business major, and 6 undeclared majors. Okay, so the first one, what is the probability a randomly selected student from this class is a business major? Yeah, okay. All right, so probability of business major. So we count how many business, right? So number of business major or frequency, right? Divide by number of sample space. Yeah. Okay. So how many business? We have 8, right? 8 over sample space. So we have, you calculate 7 plus 2 plus 3 plus 3 plus 1 plus 2 plus 8 plus 6. Yeah, there's a 32, 8 out of 32. So 0.25, thank you. Okay, second part, not business major. Okay, so we are using complement rule, right? So second part, so means complement, right? Means complement rule. Yeah. All right. Probability of not business major. Yeah, we can do that. We can do 2 ways. Yeah. So frequency of number of non-business major, right? We can do that. Let us do this one first. Then we are using the formula, right? Over is number of sample space. So not business major. So that will be 7 plus 2 plus 3 plus 2 plus 1 plus 2 plus business major. So and 6 over sample size is 32. Yeah. Okay. Then we get 24 over 32, which is point, what do you get? 75. Good job. Yeah. Okay, so this is easy to calculate, right? But not all the time easy for the calculate complement rule, right? Not business major. So what we are using, we're using the formula, right? So the formula is here. What is not in the E, then 1 minus what is the in of the probability, right? So let's using the formula. The formula said that na E is 1 minus probability of event E, yeah? Okay. So there will be, what is the probability of not business, right? Not business major. Major. So there is 1 minus probability of business major, right? Business major. Okay, there will be 1 minus. What's the probability of the business major from the previous question? We have 8 over 32, right? So, or we can use the decimal so that we don't have to make a common denominator, right? So 1 minus 0.25, easily to calculate 0.75, right? So this is more easier, yeah, if we know the formula, right? Okay. Okay, so I insert a Venn diagram here again. So here is business major. It's not business major for a complement rule, right? Okay, now we are using percentage of complement rule. So it's like this. If we say that 30% chance of rain, then what's the complement rule? Complement, not the rule, complement, complement. 70% is not 70% chance it will not be rain, right? Yeah. So let me write down. Okay, so let's take a look this example. According to few research raised in America survey in 2019, 68% of Black Americans feel that being Black hurts their chance to get ahead in this country. Express this as a probability and find and interpret the complement. Yeah, so let's using complement rule for this one. We can just using 68%, right? So 68% was the opposite, like a 70% chance will not be rain, right? So we get 32%, right? If we are using the rule, so let's do it. We have probability of the opposite will be not hurt chance, right? So being Black does not hurt chance. There will be 1 minus probability of hurt chance, right? In Black hurt chance says, yeah. Okay, so there will be 1 minus. Okay, so when we calculate, we have to change it to number, right? From the percent. So from the percent, how do you make a number? We make a decimal, right? So how do you make a decimal? We times 0.01, right? So we have 68% times 0.01. So we take out the percent notation. So this means we move to the decimal point. Pretend the decimal point here, 68 is the same as 68.0%, right? So 68. So pretend the decimal point here, we move to the left twice, yeah? Yeah. So I called this is Beyonce method, right? But look, why Beyonce method? Because her song, we have to the left, da 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 da, da to the left. But not many students knows that. You are too young for that, right? Do you know this song? Replaceable like that? Okay, so 0.68. All right, so we have a 0.68. Then we calculate what we have. It's a 0.32. Yeah. So how do we interpret? Let me write down. Um, if we have 68% of Black American feel hurt being their chance, then we have 32% do not feel being Black hurts their chance. Okay? Okay, I wrote down here what I said earlier, right? And then Black hurts their chances means their race made it harder for them to succeed or move ahead in life. For example, in jobs, education, or opportunities. Yeah. Okay, so let's move on. New concept. Okay, so we have this question, example 3. We have a table. We want to find the probability that randomly selected person has one tattoo or more than one tattoo. Okay, so let me write down what's the probability of has one tattoo or more than one tattoo, right? Okay, how do we do? So number of, right? So, or frequency, same, right? So that, ooh, I just want to just copy this one, copy, and divide by sample space, right? Yeah, number of sample space, yeah. How many sample space? There will be 59 plus 13 plus 35 plus 5. How about or? We have or. How do you do? Yeah, we just add them, right? Could be one tattoo or more than one tattoo. So we add them. So we will get the 13 plus 35. Yeah. Can you calculate? It's a 48. Good. Over 102, right? Okay. I think I didn't mention that, right? So probability is between 0 and 1, right? So it's a tiny number, right? So normally we answer at least 4 decimal places. Yeah. Okay. So what do you get? 4. So then we have to round off on the 4 digit, right? Tenth, hundredth, thousandth, 10,000th, right? So 0.4286. Yeah. We have disjoint another terminology. So we have two events are called disjoint if they have no outcome in common. So also we called mutually exclusive. So like my name goes by Michelle and Minyoung Lee too, right? So disjoint also mutually exclusive. Yeah. So I'm gonna show you as a Venn diagram. So this joint looks like that. So we have event E, event F, disjoint, mutually exclusive, right? Mutually exclusive. Okay, so let's just say that sample size from 0 to 9. Let's say let's say event E has even number. Number. Okay, so we consider 0 is even number, so 0 to 4, 6, 8, right? Event F has odd numbers from the sample size. Then there will be 1, 3, 5, 7, 9, right? So they are disjoint. Yeah. Okay, now we have disjoint event probability. So we have a statistics class has 32 students enrolled. They have seven. Oh, this is the same as what we did earlier, right? So 7 nursing major, 2 journalism, blah, 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 right? The first one are the least majors disjoint. What do you think? Yeah, they don't say that. Like what is called double major or minor major, right? Yeah. So we can guess they are disjoint, right? So disjoint. They are disjoint. They don't mention that students taking minor or double major since there is no double or minor majors. Yeah. And then second part, find the probability that randomly selected student is nursing or kinesiology. Kinesiology. Am I correct? Kinesiology. Kinesiology. Major. So how do you do? Is disjoint? Yeah. And then we have a or part, we know that add, right? Yeah, we can do that. So that will be probability of nursing or kine. Let me just using like that, right? Using like that. Yeah. Hold on 1 second. Okay, so there will be how many number of nursing major or kinesiology major over number of sample space. Okay, so that will be sample space we had earlier, 32. And nursing, I can see the 7 plus kinesiology has 3. So which is 10 over 32? Can you please calculate? 0.3125. Yeah. Good job. Okay. Now, from this one, we can derive the formula, right? All right, so if we have OR part, and then if we have a disjoint, then we can just add to probability. So let me highlight. Uh, if event or disjoint, if we have OR part, we can just add them. Yeah. All right, so we have this example. So let's do it. All right, so let's do this example. So find the probability that randomly selected eligible voter is Black or Hispanic. So we have to determine whether disjoint or not. So what do you think? Yeah, so we have the table, right? So Black, Hispanic, Asian, white, other. So we determine this is the disjoint. So we can answer that. Probability of Black. Recording, right? All right, so we have probability of Black or Hispanic. Hispanic. Okay, so there will be number of or in that case is a probability, right? So probability of it's stuck. Okay, hold on 1 second. So we have a probability, right? So instead of a number, we can say the probability. Okay, then how about, let me just copy. How about this? We don't need a number of sample space, right? So we can just copy Black, and then or means addition. So we add them. Probability of Hispanic, right? So there will be, we can just using that information, Black, which is 0.1277 plus Hispanic 0.1250. Can you please calculate? 0.2527. Yeah. Okay. Second one, you can try. All right, second one, right? See, non-white, how do you do? So it's a complement, right? So see, complement rule. We can apply. So probability of non-white, there is 1 minus. What is opposite? Think about the opposite statement or phrase, right? So there will be 1 minus white, probability of white. Okay, so there will be 1 minus, what's the probability of white? 0.6742. Now, can you please calculate? It's 0.3258. All right, thank you. Oh, you cannot see. Sorry about that. All right, so we did that disjoint event, which is mutually exclusive, means that two events they don't have the same comma, right? They don't have their outcome does not have a comma, right? Now we have a non-disjoint event. So two events are not disjoint. Their outcome is in common, all right? Let me highlight here. Common outcome. Non-disjoint, common outcome. Yeah. All right. Okay. So what this mean? Let me give it to you with the numbers. So we have a sample space from 0 to 9. And event E has, I'm gonna pick random number, or you can give it to me. 0, 1, 5, 7. Yeah. How about event F has 0, 2, 3, 5, and 6, 8, 9. How about that, right? All right. Okay, let's talk about the probability, right? So probability of event E, then number of event E over number of sample space. So what do you get? It's a 4 out of 10, right? Which is 0.4. How about probability of event F, right? So there will be number of event F over number of sample space, which is 7 out of 10, which is 0.7. Look, we had, by the rule, all the probability must be between 0 and 1, inclusive of 0 and 1. Then their sum must be equal to 1, right? So let's add them. They must be equal to 1. Okay, so 0.4 plus 0.7, what do you get? Uh, it's not point, it's 1.1, right? 1.1. Yeah, this is not 1, right? Their sum must be equal to 1, right? So this violated the probability rule, right? So why this is over 1? Looking at this one, so we have 0.5 there, also 0.5 there. We count twice, yeah? If I want to draw Venn diagram here, so we have event E, event E, and event F. Ah! Sorry. Event F. Okay. So E and F. So 0.5, they have a common. Yeah, they share, right? They both have a 0 and 1. Yeah. Okay, then 1, 7 there, and then 2, 3, 6, 8, 9. Yeah. Okay, then how do we make their sum must be equal to 1? Since we counted twice 0, 5, in that case 0, 5 twice, right? So we have to take it out, count 1 from here. So that means we have a probability of event E plus probability of event F, and take it out, which is probability of event E and F. Then take a look. So we have 0.4 plus 0.7. Okay, then what is probability of event E and F, which is 0 and 5, right? And sorry, there is missing 4. Let me write down 4 there. So sorry about that, missing 4. Yeah, so 3, 4. 4 was the missing. Sorry about that. Yeah. Then there will be 8. Okay, so 8, 8, 1.2 then? Okay, so 8, yeah. All right. So once again, 1, 2, 3, 4, 5, 6, 7, 8, right? So 0.8, 0.8, fixed that everything. All right, then we have in the case, what's the probability of event E and F? It's 2 out of 10, right? Oops. 2 out of 10. That's a 0.2, right? So there will be 0.4 plus 0.8 minus 0.2, which is 1. We can see that their sum must be equal to 1. Yeah? Make sense? Okay, so this means we take away probability of event E and F means something overlap, right? So overlap. So overlap. So event E and F, right? So that numbers belong to E also belong to F. Make sense? Both event. Both event. Yeah. So everything, this means we take away, this means the common outcome counted twice. So we take out one count. Yeah. Make sense? Okay, let's move on. Okay, so let's do this example. 40 students enrolled in a statistics course. Professor finds she has 18 students also taking English and 12 students also taking history class. There were 3 students who were taking both English and history, addition to statistics, right? So let's make a Venn diagram here. All right, so we have sample size, which is a 40, right? So 40 students in the statistics course. Statistics course, yeah. And then 18 students take the English, right? English class. And then 12 students is the history class, right? Yeah. I wanted to make a different color, but it's too late. All right. Then there were 3 students taking both. So 3, yeah. So 3. Then 18 minus 3, what do you get? It's a 15 there. And then 12 minus 3, it's a 9 there. right? So that 15 will be take the English, not the history, right? Only English. How about that? How about we have 9 only history, yeah? Okay, so let's answer this one then. A part, what is probability that taking English class, right? That means, so from the statistic, taking only English, right? So A probability of English. So there will be number of English class and then over number of sample space. What's the sample space? How many of sample space? 40. Good. How many for English class? 18. Yeah. So don't get confused with 15. Yeah. 15 is the not overlap. So there were 3 students taking English and history, right? So just we answer English class, that 18. Make sense to you? Not the 15. Yeah. So 18. All right. So what do you get? 0.45. Okay. What's the probability of history? So how many history? They say that 13? No, 12. 12, right? 12 students taking the history, right? Yeah. Number of sample space is 12 out of 40, which is 0.3. Okay, good job. Now, both English and history, there's the overlapping part. English and history. So that's the common part, right? So English and history over number of sample space. So we have n here and common outcome. So think overlapping part, right? That is a 3. Make sense? Okay, 3 out of 40. Yeah. So what do you get? 0.075. All right. The last one we have, what is the probability also taking English or history, right? So or part, we add them, but then we have to determine whether disjoint event or not disjoint event, right? So disjoint event, we just add. Not disjoint event, we have to take away, count twice one, overlapping part, right? Yeah. So what do you think? Since the Venn diagram is like this, not disjoint, right? Not disjoint. Then not disjoint means they have a common outcome, right? Common outcome we had earlier in part. Okay, so let's do that. English or history. So we have or addition. So that will be probability of English plus probability of history. And let me make a little bit smaller so that I can make one line. Okay, then take away English and history. Yeah. So that part is not disjoint part, right? Not disjoint. Okay, so we have from part one, a 0.45, the probability of English, and part B, probability of history, we have 0.3, and take away overlap. That is the C part. Oh, that's why they have everything in order, right? Good. 0.075, right? Now, can you please calculate? 0.065. Okay. All right. Any question? Okay, then we can derive the formula. Let's take a look. All right, so we had a formula I introduced you earlier, right? Yeah. So that is the formula. So what's the probability of event E or F? We add their probability and then we take away overlapping part, right? So this is not disjoint. Oh, why they don't indicate that? Because we can use disjoint too. So when we have a disjoint, this one is 0. Not disjoint, there is some number. Let me write down. Disjoint, if disjoint, then this part will be 0. Because there's nothing disjoint, right? So nothing overcome now overcome overlap, right? So this part is 0, not disjoint, then there is some numbers, right? Yeah, there we go. So they mentioned it here too. Yeah. Okay. Or and versus and or versus and. So or part or the outcome must be event E or F or both, right? So it could be at least one event belong to at least one event. That's the or. And must be both, all the event. So let me write down. Think the outcome must be only at least, we can use at least, right? At least one event. Yeah, means they can be one event or both, or there is more event, more, right? And part and all event, right? So the outcome must be A event, B event. If we have a more event, then A, B, C, D, multiple events. Make sense to you? All right. Okay, so let's do this example as the last example for this section. All right, so we have this table, this is a two-way table. So we had this experience, right? Contingency table, right? So let me write down contingency table. Contingency table. Okay. So let's answer the first one. Field race, ethnicity should be major factor. Okay, so we have two variables, right? So ethnicity and then major the factor, right? So factor. Okay. Now the first one, uh, probability of major factor. Okay, so there will be number of major factor divided by number of sample space, number of total frequencies, right? Same thing, right? Let me write down. So frequency, so frequency, number means frequency or the total number of frequency, right? Total number of frequencies. Okay, so major, we read this way, right? Major, yeah, 609 over the sample space, which is total number of frequencies, which is 6,421, right? Can you please calculate? Yeah, 0.0948. Okay. Second one, minor factor. Probability of a minor factor. So number of minor factor over number of sample space. Total number of frequencies the same. So minor factor, we read this way. Minor factor 1,285 over 6,421, right? Can you calculate? 0.2001. Good. Now, C, fields, race, ethnicity should not be a factor. Okay, so probability not a factor, right? So number of not a factor divided by number of sample space. Okay, not a factor here, so 4,527, right? So that would be 4,525. Let me double check. 4,527, not the 5, 7, divided by 6,421. Yeah. Can you please calculate? Okay, 0.7050. Okay. Next one, Hispanic or things it should be major factors. So or part, we have to use the formula, right? So or, so let me write down or probability of event E plus probability of event F minus probability of event E and F, right? Disjoint the last term is 0, not disjoint, we have to calculate, right? All right, so, or using this one. Okay, so there will be, oh, no. Let me, okay, let me bring this one. What's the question? Hispanic? Not, Hispanic? Major factor, right? So Hispanic major factor. So probability of Hispanic or major factor, right? Major. Let me denote it like that, right? Okay, so there will be probability of Hispanic plus probability of a major factor and take away Hispanic and major factor, right? Okay, so Hispanic. So how do we read? I want to bring this one. I should have. Okay, let me copy new one. Let me pause. Copy new one. Okay, here is. So probability of Hispanic, number of Hispanic divided by number of sample space plus number of major factor over number of sample space minus number of Hispanic and major factor over, sorry, so small. Then number of sample space, yeah? Okay. Let's take a look. Sample space is the same. We had 6,421 there, right? 6,421. Hispanic. So we read here, right? Hispanic. So this one, right? 574 plus 6,421. Major, we had a major earlier, right? Major. So major, we're using this color, I think. 609, right? So 609. And is there Hispanic and major? Yes, because Hispanic Hispanic actually they add everything up. That's why 1,074 there, right? Major also, they add everything up about the ethnicity, right? That's why they have a 609, right? Can you see that I highlighted the column and then row twice, right? 173 is Hispanic major factor. That means 173 counted twice here, right? Twice here. So we want to take it out one count from there, right? So M part. So there is 173 over 604 or 6,421, right? Okay, now can you please calculate? Yeah. So everything. So it's a 0.3130. Excellent. Okay, let us do the last one. Oh no, two more. Okay, we have also or part. So similar, right? So black things or things it should be minor factor. So black and or minor factor. Let's do it. Yeah, let me denote it this way, right? So same number of black over number of sample space plus number of minor over number of sample space. And then or part, we have to use that formula, right? Number of black and minor factor over number of sample space. Okay, so that will be 6,421. Okay, black we are using here, right? So we get 1,518. And then minor, I think we had this color earlier, minor. So we have a 1,285. Okay, is there overlapping part? Black and minor, right? Yes. So let's take a look. Actually, that black total counted everything from here, right? And then we have a minor, counted everything, that row, right? So 304 counted twice. That column, this row, right? Twice. So we need to take it out once. So that is 304. Now, can you please calculate? So which is 0.3892. Thank you. All right, so last one. So last one we have n part. N means we are using just overlap. Yeah. So outcome is in there, also there, right? So in that case, the number is there and also there, right? So overlapping parts, so white and not be a factor. Okay, let me write down. If white and not a factor, right? Okay, so there will be number of white and not factor divided by number of sample space. Okay, so what do you get? So 6,421 and white not be a factor. So overlapping part, right? So white and not be a factor. I was using this color earlier, blue. So not be a factor. So that would be 2,338. Yeah. Overlap. So what do you get? So 0.3641. Yeah. Okay. Thank you for watching. I'll see you in the next video. Bye.